Hello everyone, welcome back to my channel. So today we are going to see about this topic called distillation. This is a topic in mass transfer operations. So today we are dealing with one of the main thing here called relative volatility. So in distillation we are considering the property of the fluids called volatility. Volatility means the property of any fluid where it evaporates easily. That's all. So we are using one more term here called relative, means we are taking some reference and then we are considering what type of fluid will evaporate easily compared to the reference fluid. So that's why we are using this term relative volatility given by the symbol alpha, which is also represented as alpha AB here. AB are two components which we are going to separate. So why A XA, all these are the mole fractions. Y is for gas phase and X is for the liquid phase. When Y is greater than X, so we get the alpha value as Ya by Yb whole divided by Xa by Xb. Alpha AB will be equal to Ya whole divided by 1 minus Ya whole divided by the ratio Xa by 1 minus Xa. Here what we are doing means we are just taking two components called A and B. First here we are taking the component A in the numerators, component B in the denominators, and we are trying to give the ratio. We have made here one ratio that is represented as capital Ya, where Ya by small ya by 1 minus small ya will be the ratio considered as capital Ya. Similarly for Xa, see Y is considered for gas phase and X is considered for liquid phase. This must be very clear to you. Next here we are seeing the value of alpha will depend on the upon the composition of the component. Okay, coming to this conditions here, see if the alpha AB value will be equal to 1, our ratio will have to be equal to 1 as well. This is the simple logic for any equation. We just equate all these terms and we are getting some two conditions here. When alpha is greater than 1 and alpha is less than 1. Okay, so Ya will be greater than Xa if alpha greater than 1, if alpha less than 1, Ya is less than Xa. So this much we have to remember. Now we have mole ratio of the components in both vapor and liquid phases. So we have given that in this equation. Next we have two of the graphs here. We are showing the alpha values. Alpha equals 1 is considered to be for the ideal liquids, ideal fluids. In this case, always the compositions of X and Y are less than 1. So we have two cases here. If it is having alpha value less than 1, it will be 0.1, 0.2, 0.3 and it will be below the diagonal line here. And above the diagonal line we have alpha values greater than 1. So in azeotrope the alpha equals alpha AB will be 1. So this shows as alpha increases, Y is greater than X. Distillation will be occurring only at temperatures between bubble point and dew point temperature. This is denoted here with a graph. So I hope you are trying to understand. This is the ideal fluid line, and then we are getting some graphs like this which are slightly curved and bent. So here we are dealing with the during the process of condensation, the first liquid drop appears on the surface is the dew point temperature. In this, most of the feed is in the vapor form, liquid tends to 0. So when the feed is in vapor form, the liquid will be tending to 0 or there is no liquid present, it shows. So now we are using Dalton's law of partial pressure and Raoult's law for the liquids. At equilibrium, what happens is we get the partial pressures in gas phase and liquid phase for one of the component here called A. So we are trying to equate it, our total pressure into gas phase pressure, gas phase mole fraction equals partial pressure of component A and its liquid phase mole fraction. So that we are trying to equate again in the ratios form. We just equate this ratio once again and try to simplify it further to get this equation. Here we are again considering these components x and y, they are the mole fractions, and then temperature on y axis, and then we get a graph like this as a curve. Again we are getting t xy plot here. Again we are taking here one reference point. Then we have dew point. This is the dew point here. Below will be the bubble point. This is vapor liquid in between, and the liquid will be below, vapor will be in above. Above dew point it is pure vapor, below dew point it will be below bubble point it is liquid. So what are the states of the fluid we are just trying to show here. Again we are considering enthalpy, that is H equals U plus PV. It is the simple thermodynamics we have studied. Also it is directly proportional to the temperature here. So all these terms will be connected with the temperature itself. However, our temperature will be changing, then only our things will change. So the state of the substance changes. So we have to remember this much. So I hope you understand.